Hello everyone. In this video, I'm going to show you how to simulate a swirl flow. Um, I have received these files via one of our um, channel's subscribers. He or she asked me to um, do the swirl flow simulations, and also the user shared with me these PDF files and the the diffuser's geometry. I will put the um, Google Drive link the user shared with me in the description, so you can access that CAD file if you need. So this is a diffuser kind of used for, I believe, in HVAC systems. So there's an inlet air from these holes, and it creates the swirl flow to enhance the air mixing, maybe, or heat transfer in this case, maybe. What I will do, I will create a Fluent block. So I will open the design modeler. So this is a good example. I will show you how to use a CAD file and subtract the Floyd, kind of create the flow region. So in the import external geometry, and I will go to drive. So I have converted that SolidWorks part to a step file, or you can use the XT file, which is a smaller file. So I will open this XT file, then generate. So let me change the view. So as you can see, this is the diffuser. So we have these inlets from here, and the outlets should be these parts, so which creates some swirl in the flow we will see after the simulation. So here, let's see how can we um, create the flow domain using this part. So let's create an extrude. So let's select this edge, apply, and let's do the add frozen, so it will not merge the new geometry with this old one. Direction, we can select one of these edges. So instead of fix, go to up to surface. So I wanna extrude this Floyd up to this surface, which is bottom of that um, output part. So create, generate. So let's rename this one as a diffuser. So let me hide this diffuser. So it created simple cylinder there. So the later will subtract this one from that part to create the Floyd region. Next, let's create another extrusion. So let's do from the same surface. By at frozen, direction same. Okay, so fix to surface. Select this top surface. Apply. And you can see there's another. If I hide these two, there's another disk created here. So show all bodies. Okay, let's first merge these two together. Boolean unite. Apply. Okay, so we have two bodies. So I will subtract the diffuser from the those two cylinders. Let me hide these. This one you can see we have a like cylindrical shape with the top disc, but now it's a single body. So let's create another boolean. So use subtract. Target body will be the Floyd one. Tool body will be the diffuser. Okay, we don't need to keep the diffuser here. Okay, you can see here, this is the Floyd domain. These surfaces, these are the inlets, and this should be outlet to the room. So now I wanna add um, some domain as the room to see how the Floyd circles or swirls as it exits the diffuser. So I need to have another domain up here to see the behavior of the Floyd after exiting the diffuser. Okay, for this case, I will create a new plane on top of this one. So I will use the XZ plane, I will click this one, create a new plane, from plane, XZ plane. So I will need to offset this plane to this surface. So how can we find out? Let's generate this one first. So we have the plane on the ZX plane. How we can find out what's the distance of? So as you can see, the ZX plane is exactly at the bottom of the surface. So I wanna see what's the distance difference from the zero to this surface. So I will select one point here, any point on the surface, go to the tools, analysis tools, entity information. So since this is in the global Y, so this is 0.123 or 123 millimeters. Let me change my units to millimeters. So I will go to this plane and right click, edit selection. And for the transform, I will do offset Z. Why offset Z? Because I'm not doing the offset globally, I'm doing offset based on this new plane. So 123 millimeters. So if I do the generate, I will have a plane in the center of the circle, but the zero is the surface. So I can add a new domain and merge with this one. So let's look at top, create a new sketch. So we can do a circle shape or rectangular shape, doesn't matter. Let's create another circle shape. What's the diameter? Let's do like 500. This is not large enough, but to have a smaller domain, we can do this to 600. Okay. Let's go to the modeling, click the sketch, extrude, apply. We can do the add material, so it should merge. This one instead of 30 millimeters, let's do 500 millimeters. Generate. So this didn't merge these two together. So I will select these two, Boolean, unite, generate to Floyd. Okay. Now from here, in this video, I will do the meshing using the ANSYS workbench mesh, but I want to create another video with the same geometry to create and import that geometry to the Fluent and do the meshing inside the Fluent. So which I think it might be useful. So for that purpose, I will define the name selections here in the design modeler. So I will click here, select these surfaces, which is our inlets. Okay, I've selected all of these inlets. So I will right click on this one, name selection, apply, and inlets, generate. I will define here as outlet, or I can define all surface as outlet. I will just define this one. Also this part as outlet. It depends on how you wanna do the simulation, but mostly we are interested in this area, so I can do both. Let's do just this surface, name selection, outlet, generate. Actually, let's do another name selection. So in the Fluent, we can have the option to defining this one as the outlet. So side, walls, and generate. Okay. So I will export this geometry. So I will do the geom to Fluent. So I will keep this one for the next video. I will repeat this part up to this part to the next video. But in this video, I will close this one and open in the meshing. Okay. So let's create the mesh without doing any setting to see how is the mesh, how does the mesh look like. Then we can adjust the settings. It's good to see the meshing at first and then adjust the meshing afterwards. Okay. Now we have our meshings. As you can see that near the inlets, we don't have fine enough mesh. So it might be okay for the rough simulation, but I wanna do a little bit finer mesh here. So I will do go to the select mode and do the box select and select these. Go to this face selection and select all of these surfaces below that main cylinder and define a sizing. Sizing with instead of 52 millimeters, I will do say 10 millimeters. And also for the main mesh size, I will reduce a little bit this one for say 40 millimeters. And also, as you can see, we have our name selections here since we did the selections in the Fluent, in the um, design modeler. Let me clear the mesh. Okay. Okay, you can see that we have our inlets here, we have the outlet, and we have our sidewall. So I will click generate mesh. It will take a while, but I will come back after the mesh is finished. Okay, now the meshing is done. So let's see. It looks fine enough. So what I'm planning to do is convert this mesh to polyhedra mesh in Fluent. So let's do a section plane. Check the mesh size. You can see it's a fine mesh. It's not a perfect or good enough mesh for any engineering application. So you need to have a finer mesh in this area, define some um, near wall layering. So I will do that in next video when I'm doing the Fluent meshing, which is it's a very good meshing, automatic meshing software. So I will show you, especially if you are um, not very good in meshing. So you can look to that video later to check out how to do the better meshing inside the Fluent. In this ANSYS meshing software, if you want to do that meshing, you need to insert, um, for example, inflation, um, insert inflation, and define the near wall boundary. I just want to show you how to do that here. So later, I will talk about that later in Fluent meshing. So let's update our meshing so it will send the files to Fluent. I will close the open the Fluent. The parallel version. I have 8 CPUs. I'm using Intel MPI. So if you could send if you have any question or any problem like this one, you can send me more details about the project or some papers with the geometry so I can do the simulation. So I'm waiting until this is being loaded. So I will put the link in the description as I mentioned before. So there will be some PDF files I can show you here. There are some papers or these PDF files along with the SolidWorks geometry. So you can access that one from that Google Drive until that user cancels the access to that folder. Okay, I'm getting an error, but I don't know what is this. So okay. So I will use the laminar model for now because first of all, let me convert our mesh to polyhedra, which has a better um, converging behavior, and also it's faster converging in the Fluent. So, and it will increase the quality of the mesh most of the time. Might take a while, but let's wait. Okay, it's done. So it suggests to do the reorder the meshing because we are using the parallel version, so it will kind of optimize the CPUs based on this new mesh. So Fluent runs one line at each time, so I will run the first line first. Now I will run the second line. Okay, now let's do the mesh display again. So as you can see, we have now converted our mesh to polyhedra, which is very cleaner and faster mesh in most of the cases. So let's use the viscous laminar flow. We don't need to do the energy equation solving and keep the same everything as default. So since this is a air diffuser, as I checked from the documentation, so I will keep the fluid zone as the air, as you can see here. So let's go to the boundary condition. So let's define as a 1 meter per second. It's maybe very high, but it will show the effect better. Or you can, let's try with this one. So if it's high, we can reduce that number. I will keep other things the same and do the initialization. In your case, before converting the mesh to polyhedra, you can initialize and initialize with the default mesh, then convert to the polyhedra and initialize again. You can see how it's faster and initialized. The values goes to the lower error number, even in the initializing part. So let's define 200 and run the calculations. So it might take a while, so I will come back. I will pause the video and come back when the calculation is done. Okay, now the simulation is done. Let's click OK, and I will quickly show the path lines here. Then I will move to CFD post to show the visualization in that. Okay, let's do the velocity instead of particle ID. So as you can see, we have a very good swirl here. I will move to CFD post because that one has a better visualization. So I will close off the Fluent. Now let's open the CFD post or post processing. Okay, now we have the post processing here. So actually it should be, if it's on a sailing, it should be this way. So I just wanna, so it should be from top to bottom. So, but for convenient, I will use the default orientation. Let's create a plane on YZ plane. OK. So I will hide this plane, create a counter, location plane 1. So let's create the velocity. So as you can see, let me increase the number of counter lines and don't show the counter lines. So you can see that how the velocity is changing. I can hide this wireframe so you can see how, sorry about that, you can see how the velocity is changing. Let's change this legend view to fixed, precision 2. Okay. Now let's visualize the path lines. So I will hide this counter and show this wireframe. Create the streamlines. So starting from the inlets, and let's click apply. Okay. We need to increase the number of the points. Let's do 100. Why? That's better. So let's go to symbol, create a tubes, or you can use the ribbons if you wanna. Okay, tubes looks better. Okay, as you can see, it shows this ribbons and this tubes shows the how the fluid is like as it enters like these inlets and comes out of these outlet kind of swirls and creates a very nice turbulence or mixing in the big cylinder, which is represents of the room or the space. Also, we can hide these streamlines. Apply. Go to animation. So let's first show these streamlines. We can create an image like white background, so that double the size of the screen. It will be saved in the location we have saved the our project. So let's hide these streamlines. So okay, looks nice. So let's make it slower. So go to the options. If you reduce the spacing, for example, 0.1, so you will see more continuous fluid. So for this one, it's better to show the fluid with arrows, I believe. That would be better. Okay, I will wait until it's stopped. Okay. So let's do the increase the quality of this video. Let's do the 3D arrows. Okay. Okay, we will need a little bit larger arrows. So create one. Oh, I changed the spacing instead of size. Let's do 2. Okay, it looks better, but Okay, let's do very small spacing and a little bit larger the arrows and use the white background. Okay. Okay, it looks better, but I think the arrow size is still big, so we have like this turning here. And also spacing is too small. Let's do this too, and okay. So I wanna save the movie as the MPG4. So in the user files where I save the uh, project. Okay, we can't use the repeat forever. I will just use one. So that's okay. So now it will create the video. So I will stop the recording here. Then I will attach the video to the end of this video, or I will post in a separate file. Thank you for watching. In the next video next week, I will create the same geometry, same simulation, but in that one I will use Fluent meshing. I will explain how to do the meshing in the Fluent. If you're interested, you can watch that video later. Thank you again for watching, and if you like this video, please press like and subscribe to our channel for more videos. Don't forget to comment on under this video and other videos in our channel. If you have any questions, please leave the questions on the comments. I will try to answer as good as I can, or like this video, if you have a specific problem in mind, please post more details or send the geometry files or related papers, so I will do my best to put tutorials based on your needs. Thank you for watching.